Hello and welcome to Algebra 2 CST release question 49. It says the graph of the quantity x divided by 2 squared minus the quantity y divided by 3 squared equals 1 is a hyperbola. Which set of equations represents the asymptotes of the hyperbola's graph? And so some background information first on hyperbolas. What's a hyperbola first of all? So I'm going to show you a couple of different ways, just some quick sketches that you might see a hyperbola. So you might see it with the foci, that is plural for focus, with the foci oriented along the x-axis, or you might see the foci oriented along the y-axis. So I'm going to show you both of these and then both general equations that go with that. So here we have foci oriented along the x-axis that could look something like this. I'll draw this and I'll go with blue. So it could look something like this, where you have one focus and another focus over here, and the hyperbola looks something like that. And so what is then an asymptote? Well, an asymptote is these lines which the hyperbola never actually touches. So not my best work right there. It is just a sketch, but should go through the origin, at least the way I'm doing this one. Okay, so these lines, I'm saying that the hyperbola, the graph of the hyperbola is never going to touch that. As you extend this farther and farther out, it never actually crosses that line or this one. Likewise, the same thing over there. And then similarly with the foci along the y-axis, if it's oriented like that instead, so you could have this and this, it would look like something like this, where the hyperbola now is going in this direction that way, and then in this direction opening down that way. You still have these asymptotes, these lines that the graph of the hyperbola never actually touches. Again, just a very rough sketch, just trying to give you an idea of what a hyperbola looks like by doing this. And what these foci are, if you were to actually take a point right here, connect it to a point on the hyperbola over here and here, there is this common difference, or this constant distance that these things are away from each other. So if I took this, and I found a couple other points, if I go like this, and I take this segment length minus this one, it's going to equal the same thing as this one minus this one, which will be the same thing as this one minus this one, and so on. So that's really what a hyperbola is. And there's some pretty cool applications to that in the real world. We're not getting into that here though. So the same thing works over here, but in general, what's the form? Or what's the formula? So in general, what's it look like? Well, if they're oriented along the x-axis like this is my x and y, with the foci along the x-axis, in general, it's going to look like this: x squared over a squared minus y squared over b squared equals 1. This is our general form that we refer back to. In general, over here, if you have them oriented along the foci along the y-axis, instead you're going to have the y coming first. And we still use a squared and b squared. Now with this problem, I'm not getting into all the details. Really, with these conic section problems, with things about parabolas, hyperbolas, ellipses, circles, you really should study a little more in depth. If what I'm talking about here doesn't look familiar at all, you really got some work ahead of you to make sure you get a true grasp of everything that's going on with these things. But this is kind of in general what hyperbolas look like, and then the general forms what we have here. And so what I have here, I could rewrite, I'm going to rewrite it down here, I could rewrite this as, I can kind of think of distributing this power to both the top and the bottom, both the numerator and the denominator. So I have this over this, and I have this over this, 3 squared, which equals 1. I can think of that like this as well. So these are three equivalent ways to think of the same equation, but it's helpful to think about it as kind of this squared and this squared, because you have a squared and b squared. So what form are we using? Well, this one has the x coming before the y. This is where you have the foci oriented along the x-axis. And so we're going to be using this form in this particular problem. And so from there, we need to know what the equation for the asymptotes are. If we're using this form, the equation for the asymptotes becomes what I'm just about to write down here. So if we have this form, the equation for the asymptotes is going to be b over a times x and negative b over a times x. And so we're not dealing with this stuff anymore because this is how our particular problem looks here. If you use this though, if it was this form, it would actually be a over b times x and negative a over b times x. And so we're going to use these two things, and now it's just simply a matter of figuring out, well, what's my b and what's my a, plugging in the numbers, and then you've got your equations that you need. And so let's take a look over here. What are my b and a values? My a squared is 2 squared, and so I have this is my a value right here, and my b squared is my 3 squared. And so I'm just plugging those values in now. I've got y equals b over a is 3 over 2 times x, and I also have y equals negative b over a, which is negative 3 over 2 times x. So these are your equations for the asymptotes. These would be the green lines in a sense. I'm not drawing this to scale at all, but these would be the green lines, the equation of those lines which the hyperbola would never actually touch. It would get infinitely close to that line as you extend it out farther and farther, but never actually touch. So 3 halves x, negative 3 halves x. What choice is that? It looks like choice A for number 49.